Question 1f. Use the substitution u equals 1 minus x squared to evaluate the definite integral of 2x over 1 minus x squared all squared dx from x equals 2 to x equals 3. Starting with the substitution u equals 1 minus x squared, the first step is to find the first derivative of u with respect to x. So du dx is equal to negative 2x. The next step is to separate these differentials by multiplying both sides of this equation by dx. Hence, du is equal to negative 2x dx, and then dividing both sides of this equation by negative 1, we get negative du is equal to 2x dx. Now, 2x dx represents the numerator of the integrand, and that's going to be replaced with negative du. The next step is to use the original substitution to change the limits of integration. So when x equals 2, u is equal to 1 minus 2 squared, which equals negative 3. And when x equals 3, u is equal to 1 minus 3 squared, which equals negative 8. Hence, the integral of 2x over 1 minus x squared all squared dx from x equals 2 to x equals 3 is equal to the integral of negative 1 over u squared du from u equals negative 3 to u equals negative 8. Now, rather than having a negative in the numerator, we can replace negative 1 with positive 1, so multiplying the integrand by negative 1, but we need to compensate for that by reversing the limits of integration. So instead of from being negative 3 to negative 8, it's now from negative 8 to negative 3. Integrating 1 over u squared, we get negative 1 over u from u equals negative 8 to u equals negative 3. And applying the limits of integration, that equals negative 1 over negative 3 minus negative 1 over negative 8, which equals 5 over 24.